Hey everyone, welcome back to another physics past paper video. Today we're going to talk about paper 1 multiple choice from the February-March 2023, and the variant that we'll be starting with is 1-2. So let's jump into the paper. Question number 1. What represents a physical quantity? So physical quantity requires a magnitude and a unit. Okay, this is the basic requirement for a physical quantity. So this is not the no unit, no magnitude. This is the correct one, magnitude and a unit. So C would be the right answer. The relationship between the variables d and t is given by the equation where b and c are constants. The unit of d is meter squared and the unit of t is s. What are the units of b and c? Okay, so remember the principle of homogeneity that says that all of the summands over here will have the same unit. So that means 1 over t, the unit is per second, so that means c will have the same unit per second. Therefore b over, you see, this is meter squared, so this will become meter, so we need it to become per second, right? So this would be meter per second over meter, that becomes per second. So c is per second and b is meters per second. B. Okay. A hollow cylinder which is open at both ends has a radius of 0.1 centimeter and a length of 0.1 centimeter. What is the value with this absolute uncertainty with the surface area of the cylinder? So surface area of which is open at both ends. So surface area in that case would be 2 pi RH. Okay, so first we need to find out the area, then we will figure out what the absolute or percentage uncertainty is. So 2 pi times by radius times by length 50. So this is 15 times by 3, 45, 45 times by 2, 90 pi. Let's keep it exact because that's what we need. Right, okay. Then we need the percentage area or fractional uncertainty. So 2 pi is a constant, so we don't need that. So 0.1 over 3 plus 0.1 over 15. So 0.1 divided by 3 plus 0.1 divided by 15, that is 0.04. So absolute uncertainty is 4% of the value of area, which is 90 pi. So 0.04 times by 90 is 3.6 pi. Okay, now we need the actual values. So 90 pi is 282.74 and 3.6 pi is 11.3. So we need the absolute uncertainty given in one significant figure. So 10 to one significant figure would be 11 to one significant figure would be 10, and also we need to represent it the same way in need as 10, so that would be 280. Right, okay, 2 pi RH. Okay, now moving on. A snooker ball of mass 0.2 kgs has a collision so that its direction of movement changes by an angle of 90 degrees. The ball has a speed of 0.4 meters per second before collision and a speed of 0.3 meters per second after the collision. What is the magnitude of change in momentum of the snooker ball? So basically we need the v minus u over here, because m is the same. So this is your v, this is your u, right? So if we do the vector way, so this is v minus u is this way. So this is 0.3 and this is 0.4. So this is your v minus u. V minus u vector wise, right? So we can find out the magnitude of v minus u also, the change in velocity. So that would be just simply, actually we can do the change in momentum also. So because momentum is also a vector quantity. So this is your m v minus u. So if we want to find the magnitude of change, we can do the square root of 0.3 times by 0.2 whole squared plus 0.4 times by 0.2 whole squared. This will be your net change in velocity. So let's calculate. So 0.3 times by 0.2 squared plus 0.4 times by 0.2 0.1. That is 0.1. Right. A ball is kicked upwards at an angle of 45 degrees to the horizontal ground. So basically you have 45 degrees to the, oh actually that's not 45 degrees, but okay, that's fine. After a short flight, the ball returns to the ground. It may be assumed that the air resistance is negligible. What is never zero during the flight of the ball? This is easy. So acceleration is the one that is never zero. Velocity will become, vertical component of velocity will become zero over here at the highest point. The horizontal velocity also would never be zero. It always remains non-zero. And what else? Yeah. So horizontal component of ball's velocity. Yes, it is never zero during the flight. There is no horizontal component of velocity of there's no horizontal component of ball's acceleration. It's always vertical, so that will never be the right. Vertical component of the ball's momentum, that means indirectly it's saying velocity, but we know at the highest point vertical velocity would be zero. Vertical component of ball's velocity, we just said that at the highest point it will be zero. Okay. The graph shows the variation with time t of the displacement s of an object. Which graph represents the variation with time t of the acceleration a of the object? Okay. So the gradient of the displacement time graph represents velocity. So in all of these phases, this is constant. So that means velocity is constant in all these phases, whether it's increasing or not. So this is positive velocity, this is negative velocity, this is positive velocity, this is negative velocity. The only change in velocity is coming over here. It's going from positive to negative. Okay? So if velocity is constant, acceleration is always zero. However, when the velocity is changing from positive to negative, then there is an acceleration. How do we can say that? So we know that, let's assume that this is constant velocity and this has become minus v. So acceleration would be final minus initial. So final minus initial divided by the change in time, which is like, this is almost instantaneous. So this is minus 2v over t. Okay, so it's since the change is happening almost instantaneously, it will be seen as a spike. So somewhat like this. So this would be a spike, sudden change. But after that change happens, it's no longer changing. Acceleration becomes zero. Over here, the final velocity is becoming, the newer velocity is becoming positive, so acceleration is in positive direction. So D would be the right answer. Which expression defines force? Rate of change of momentum. Change in momentum over time taken. A ship of mass 8.4 10 raised to power 7 kgs is approaching a harbor with speed 16.4 meter per second. By using reverse thrust, it can maintain a constant total stopping force of 920,000 Newton. How long will it take to stop? So basically, it can maintain a total constant stopping force. So basically, like deceleration, right? So first we can find out the deceleration. So this is stopping force equals to ma, or you can say how long will it take to stop? Okay, so we, instead of a, we can use the v minus u over t. So 8.4 10 raised to power 7. Instead of a, we use v minus u, so 0 minus 16.4 divided by time. So the minus will cancel out because this 0 will go away. Right, so this will be 8.4 times by 16.4 divided by 920,000 times by 10 raised to power 7. 1497. So this is in seconds. If we convert this into minutes, 24.9 minutes. Okay, which is approximately 25 minutes. The velocity time graphs of 4 different objects are shown. Which graph represents an object falling from rest through a long distance in Earth's atmosphere? Okay, so from rest, that means u is 0, and from in Earth's atmosphere, that means the drag or the air resistive force is non-zero. So it starts from rest, right? So that means this immediately is cancelled out, right? It is falling through a long distance in Earth's atmosphere. That means we are assuming that we can say that terminal velocity will be it's reaching terminal velocity. So it's never a constant acceleration, and velocity is not increasing, it's actually decreasing. The rate of change of velocity, the acceleration itself, is decreasing due to the resistive force of air resistance. Which statement about collisions is correct? Kinetic energy is conserved in all collisions? No. No. In inelastic collisions it is not. Momentum is only conserved in perfectly elastic collisions? No, it's always conserved. Relative speed of approach is equal to the relative speed of separation for perfectly elastic collisions. Yes, this is the one is correct. When two objects of different masses collide, they exert forces of different magnitudes on each other. No, this is a direct contradiction to Newton's third law, which states that they will exert forces of equal magnitudes but opposite directions on each other. A satellite uses two thrusters to adjust its motion in space. Each thruster exerts a force of 40 newtons on the satellite. The line of action of each force is a perpendicular distance of 2.3 meters from the center of gravity of the satellite. These two parallel forces act in opposite directions. That means this is a torque of a couple. What are the magnitudes of the torque and the resultant force acting on the satellite due to the two thrust forces? Okay, so the torque would be just simply magnitude of one force times by the distance between the two forces. So that means 2.3 times by 2. So 40 times by 2 times by 2.3, that is 184. So in two significant figures, it's either C or D. Now, They are in opposite directions, they are equal, so resultant force seems to be in one direction, in this direction, up and down. The resultant force is 0. But since they are separated by some distance, it's causing rotation. So C. Okay, moving on. The diagram shows two ways of hanging the same picture. In both cases, a string is attached to the same points on the picture and looped symmetrically over a nail in the wall. The forces are those that act on the forces shown are those act on the wall. Okay. In diagram 1, the string loop is shorter than in diagram 2. Which information about the magnitude of these forces is correct? Right, okay, R1 is equal to R2, T1, T2. Okay, so first off, there is the weight also considering, right? So the weight has to be taken, right? So if we just focus on this one, right? If you make a free body diagram or focus on this picture itself, you have a weight that is acting downwards and tension is acting upwards in these 2 points. So let's say, for example, you have theta like this. Let's call it theta 1, theta 1. So this is going to be 2 T1 cos theta 1. Same case over here. Let's write the equation over here. So W is equal to 2 T1 cos theta 1. But on this side, this is 2 T2 cos theta 2. Okay, and then we have the R1 also, right? Because from the perspective of the nail, tension is moving downwards. So the same angle that you see over here can be represented this way also. So it would be same T1 cos theta. So R1 would be 2 T1 cos theta 1, and R2 would be also same way theta 2 T2 cos theta 2. So basically, since as you can see, numerically they are becoming equal to weight, so R1 will be equal to R2 in both the cases. So that means it's either A or B. Now we need to decide which one of them is the correct one. Okay, so they are not equal. So because when you equate them together, you have 2T1 cos theta 1 equals to 2T2 cos theta 2. So 2 gets cancelled. You can make a ratio of these. You get cos theta 2 cos theta 1. Right? If I'm not wrong. Right, okay. So this angle, theta 2, is smaller than theta 1. Now we know the cos graph. Cos graph actually goes like this, from 0 to 90 degrees. Okay? So the cosine of the smaller graph would actually be, so the cosine of the smaller angle will actually be higher. So cos theta 2 is actually greater than cos theta 1. So this thing is actually greater than 1. So T1 itself is greater than T2. So B would be the right answer. Right, okay, moving on. An object shaped as a hemisphere rests with its flat surface on a table. The object has radius r and density rho. hemisphere, so that means half of a sphere. Okay, volume of a sphere is 4 over 3 pi r cubed. Which average pressure does the object exert on the table? Which average pressure? Okay, so first off, we need to figure out what is the mass of this. So mass is basically the half of a full sphere, right? So since volume is half, right? So mass is rho times by half of full volume, 4 over 3 pi r cubed. So this is 2. So this is, you can say, 2 pi over 3 rho r cubed. This is the mass. Okay. Pressure is force over area. So mass times by g, weight, and area is just pi r squared, right? So you get 2 pi over 3 rho r cubed g divided by pi r squared. So as you can see, pi and pi get cancelled, r squared makes it just r. So it's just 2 over 3 rho rg. 2 over 3 rho rg. A probe is used to monitor the quality of water in the sea. This probe is suspended by a vertical string which is attached to a sphere. Stationary sphere floats in equilibrium on the surface shown. The sphere has weight 5 Newton. The probe and the string have a combined weight of 2 Newton. The density of the sea water is this. Upthrust acting on the probe and thread is negligible. What is the volume of the sphere below the surface of the sea? So we need to see the downwards forces on the sphere. So if we just isolate the sphere, the net downward force acting on it is the sum of weight and the weight of the probe and the string, 2 Newton. Okay, because this tension will cause it to bring it downwards also. So 5 plus 2, that means 7 Newton is acting downwards. That means upthrust, since it is now in equilibrium, upthrust will also be 7 Newtons. Right? Now, we know the formula upthrust, rho g v. This v is basically the volume of fluid displaced in Archimedes' principle. Or you can also say that this is the volume of object submerged. Okay, so basically the volume of the sphere below the surface. Okay, so we need this. So we have upthrust 7. Rho is 1.03 10 raised to power 3. G is 9.81. Right, okay. So 7 divided by 1.03 divided by 9.81 divided by 1000. So 6.93 10 raised to power minus 4, because 1, 2, 3, 4. That's it. D part. What is the center of gravity of an object? Not the geometrical center of the object, but the point at which the weight of the object may be considered to act. That's it. System with efficiency of 74% wastes 230 watts of power. What is the useful power output of the system? Okay, so this means that this represents 26% of the input power. Okay, so this is 230 is equal to 0.26 of the power input. So if we can find out the power input, we can multiply that by 74%. So 230 divided by 0.26 Power input is 884.615. So useful power output would be 74% of this value. So this times by 0.74, so 654, which is 650. A projectile of mass 0.25 kg is at a height of 30 meters above the horizontal ground and traveling at a speed of 15 meters per second. A short time later is at a height of 35 meters above the horizontal ground and traveling at a speed of 5 meters per second. How much work is done against air resistance during this time? So it's basically the gain. You see the speed is decreasing, so that means it's gaining height, minus work done against air resistance is equal to the loss in EK. Right? So basically the work in this case would be the gain in EP and loss in EK. Okay, so we can actually figure this out. So it is first at 30, then at 35. So 0.25, 9.81. It has gained a height of 5 meters, minus half mv squared. So m is 0.25. The speed is decreasing, so 15 squared minus 5 squared. That's it. So we need to figure it out. So 0.25 times by 9.81 times by 5 minus 0.5, 0.25 times by 15 squared minus 5 squared. Actually, that would have been just 200. Wait a second, did we make it correct? Half m u squared minus v squared above the horizontal ground. Sorry, we got the right answer, but different phrasing. So when we use this thing, this represents the work with the minus sign. This is work by air resistance. But this thing, since it has come out to be negative, minus 12.7, this is actually the work done against air resistance. So we are correct. So we will treat it as positive. Sorry, I meant it as positive. When we say work done against, we already mean we are talking about positive energy. So 13 would be the answer. Okay. A spring has an unstretched length of 4.5 centimeters. The spring is fixed at one end and the force of 35 Newton is applied onto another so that the spring extends. The spring obeys Hooke's law and has a spring constant of 420 Newton meter. What is the strain of the extended spring? Okay. So first off, we need to know okay, so strain is basically extension over the original length. Extension we can find out using this rule. Extension would be F over K, that is 35 over 420 divided by the unstretched length. See, this is in meters, we need to convert it into centimeters, so unstretched length is 4.5 10 raised to power minus 2. So 35 divided by 420, right? So divided by 4.5 times by 10 raised to the power minus 2. So we get 1.85. A wire is fixed at one end and extended by a force that is applied at the other end. Force is slowly increased from 0 and then slowly decreased back to 0. The graph line for the wire being loaded is the same as the graph line for the wire being unloaded. That means it's elastic region. It's an elastic only. Yes, elastic only because it's coming back at the same 0 extension. That means there has been no plastic deformation. In a progressive water wave, two particles P and Q on the surface of the water are fixed horizontal distance apart. Right, and P and Q oscillate vertically. Which graph best represents the variation with time t of the phase difference between phi between the oscillation of the water wave particle P and the oscillation of the water particle Q? Now, if we consider the sinusoidal wave for the displacement, this is at 90 degrees and this is at 360 degrees. That means the phase difference is 270 degrees. Now, this will remain so even if this peak comes over here. Okay, so it will remain as it is. The phase difference between these two particles will remain as it is. So it will be constant phi if we have it. Non-zero constant value. Which statement about the longitudinal waves and transverse wave is not correct? Both waves can be polarized. Yes, that is the only thing that's not correct. Because longitudinal waves cannot be polarized. The rest are correct. An observer hears a sound wave emitted from a moving source. Observed frequency is less than the frequency of the sound emitted from the user. This could mean that the source is moving away from the observer. The source is moving away from the observer. Frequency is less. Yes, that is the correct. Speed of sound in air remains the same. What is the approximate range of frequencies of electromagnetic radiation visible to the human eye? Okay, so if we extrapolate from the wavelength, so we have 400 nanometers to 700 nanometers, right? So just do F is equal to V over lambda. So three 10 raised to the power 8, 3 10 raised to the power 8. So 3 divided by 700 times by 10 raised to the power 8 plus 9. Right. This frequency would be lower, so this is 4.2 10 raised to the power 14. Nearest one is tera, 10 raised to the power 12. So this is let's call it 430 terahertz. And okay, now this one 300 divided by 400. 3 divided by 400 times by 8 plus 9, that is 7.5, so that is, you can say 750, that value, right? So both are in the same region, so D. A beam of vertically polarized light is incident normally on a polarizing filter. The filter can be rotated so that it's always in a plane perpendicular to the beam. The transmission axis of the filter is initially vertical. Filter is first rotated so that clockwise by an angle 30 degrees so that the transmitted light waves have an intensity I30. Filter is then rotated clockwise by further angle of 30 degrees. What is the new intensity of the transmitted wave? So we can take a ratio. So it's I naught cos squared theta, right? So it's the same polarizing filter. It's not like a different polarizing filter. So the first one, I30, is I naught cos squared 30. The second one, I60, is I naught cos squared 60. Okay, so we can take a ratio. So I60 over I30 equals to I naught will actually just cancel out. So cos squared 60 divided by cos of 30 whole squared. We know the values. Cos of 60 is 1 over 2 and cos of 30 is under root 3 over 2. So square would be 1 over 4. Square would be 3 over 4. Right? So this would be 1 over 4 divided by 3 over 4. So 1 over 3. 0.33. Okay. A musical instrument is made using a long tube with a mouthpiece at one end. The other end is open and flared. The musician maintains stationary waves with a node at the mouthpiece. Wait a second. Right, this is the mouthpiece then. Okay. So, there's a node at the mouthpiece. Sorry. There's a node at the mouthpiece and antinode at the other end. So there's a node and there's an antinode. The lowest frequency of sound that the instrument can produce is 92 degrees. So basically sort of where you have, if I draw it this way, you have this kind of thing. Node and antinode. Which different frequencies of sound can be produced by the instrument? So this is the fundamental frequency, right? So the next one will be like this. Okay, so if we can figure out what's the relationship between the first one and the second one, the frequency, we can figure out what multiples of frequency we can use. So the first one was just a quarter of the wavelength. So length is quarter of the wavelength. Quarter of the wavelength. So wavelength is 4L. So V is constant. So F is equal to V over lambda. So V is equal to 4L. This is our fundamental. Now if we have the next time L is equal to node to antinode, right? Half wavelength plus quarter, that means 3 over 4, 3 lambda over 4, which means that lambda is 4L over 3. So F this time would be V over lambda, V over 4, sorry, this is L, 4L times by 3. So that is 3 times by F naught. So this is the in odd multiples, you can say. Okay, so 1, 3, 5 it will go. So we can say 92 times by 3, 276. And then 5, 460. Yeah, so basically this is the C part. Right. Two waves of equal frequency and amplitude are traveling in opposite directions along a stretched string. When they meet, they form a stationary wave with 3 nodes and 2 antinodes. the frequency of both waves is doubled and a new stationary wave is formed. How many antinodes are there in the new stationary wave? So antinodes will be doubled. So first off, how you can actually do that. In the first case, you have 3 antinodes, 3 nodes. So basically sort of like this. Okay? Where frequency is V over lambda is L basically, so this would be V over L. Right, in this case, lambda is L. But now you are increasing the frequency, right? So increasing the frequency, doubling the frequency, this would mean that you are doing lambda is equal to L over 2. Right, so L would be equal to 2 lambda. So this means that you are incorporating 2 waves over here. Okay? Yeah, and similarly like this. So as you can see, you will have now 4 antinodes. A, 4 antinodes. A transmitting mast sends out microwaves of wavelength 1.5 centimeter and radio waves of wavelength 1.5 kilometers. Okay, a receiving aerial behind a mountain can detect the radio waves, but not the microwaves. It's because of the diffraction and the bending of the waves. Because the wavelength of the radio waves is actually in the same order as the curvature of the mountain, or bending of that mountain. It has nothing to do with coherent. Radio waves are diffracted around the mountain, but microwaves are not. This is the correct answer. Waves are emitted from 2 coherent sources. Which statement about the waves must be correct? They have a constant phase difference. Simple factual knowledge. The diagram shows a screen that is a distance L from the diffraction grating. The grating has a total number of N lines. Any 2 adjacent lines are a distance D apart. A beam of parallel light of wavelength lambda is incident normally on the grating. Right? Which quantities affect the distance between the first order diffraction maxima on the screen? So first order diffraction maxima. So N lambda is equal to D sine theta. This would be just lambda D sine theta. So first order diffraction maxima, basically what they're affecting is D. So D is basically like 1 over N. Right? So yes, distance between the first order. Yeah, so basically the sine theta, right? So sine theta is proportional to lambda and inversely proportional to D. Sorry, actually it's actually equal to that, so but we can say theta proportional to lambda and sine theta inversely proportional to D. That means it will be proportional to N. So L will not do anything. Right, so L will not do anything. So these 2 are correct. That means A and C are incorrect. Now we need to see D is definitely D and N both. Wait. Sorry. No. The number of lines will not affect. Sorry, I assumed that N was per some distance. So N would not change anything. So N would not do anything. So wherever N is not affecting, so this is correct, this is correct. N, because N does not affect it. Total number of lines is not affecting, it's the number of the distance between them is changing. So sine theta, right. Okay, now we need to go further. D is changing, lambda is affecting also. L has nothing to do with it. Does L have anything to do with that? It will... Oh, they're not asking about the sine theta, they're asking about the distance between the first order maxima. So yes, it will affect, because you see this is simple trigonometry over here. Yeah, so basically this would also affect it, because you see this is theta, this is also theta. So if we see the 90-degree angle over here, let's call it x between the first and the 0th order and the first order. The distance between them would be x, so x is related to x over L is basically the tan theta, right? So higher the value of theta, higher the ratio between the x and the L. So yes, it is affecting, right? So A is correct. How a wire carries a current of 0.1 microamperes. The potential difference across the wire is 10 millivolts. How much energy is dissipated by the wire in a time of 10 seconds? So energy is equal to VIT. We need to convert them into amps and amps and volts. 0.1, 10 raised to power minus 6 amps, 10 raised to power minus 3. Sorry, 10 raised to power minus 3 and times by 10. So 0.1 times by 10 raised to power minus 6 plus 1 minus 3 plus 1. That is this value. Let's convert it into this form. 10 raised to power minus 8. Sorry. 1 10 raised to power minus 8. Now we need to figure out whether it's 10 nanojoules or that. So we need to add minus 1 over here. That means we are dividing by 10 over here, but we need to multiply by 10 on this one. So this now becomes 10 nano. So this is D. What is the definition of potential difference across an electrical component? Energy transferred per unit charge. That's it, simple. Which graph represents the way current I through a filament lamp varies with potential difference V across it? So the resistance is increasing, so as you can see, if you see the secant through it, the resistance will actually decrease. The V over I ratio would decrease. So B is the right answer. The table shows the properties of two different wires, P and Q. Wire P has a cross section of diameter D. What is the diameter of the cross section of the wire Q? So we know how it is actually related. So a cross-section area is pi d squared over 2, so they have already given us that. AP. So resistance is equal to rho L over A. So if we do that, this is R is equal to rho L. Let's first figure out what the area ratio is. This is AP, and this is 1/4 of R. Length is 2L. This is 1/3 of rho, and we need to know what AQ is, right? So AQ would actually be like the multiple of over here. The multiple of A over here would make sure that the net coefficient is 1. So 2 over 3 and 4. So over here on the right hand side, it's 2 over 3 rho L over A. We don't know this one yet. And this is 1 over 4. Right? So if we want 1 over 4, we can do just simple math over here. 2 over 3x. So x is just basically cross multiplied. 2 over 3 times 2 times by 4. Yeah, so 2 4 over 3. 8 over 3. So this particular one is 8 over 3. So A of Q is 8/3 of area of P. Alright, now we need to see how that affects the pi. dq squared over 4 is equal to 8/3 of pi dp squared over 4. 4 pi get cancelled. dq would be the square root of 8 over 3. 1.63 diameter of P. So 1.6. That is correct. A cell has a constant electromotive force. Variable resistor is connected between the terminals of the city, okay? The resistance of the variable resistor is decreased. Which statement about the change of the cell's terminal potential difference PD is correct? The terminal PD is decreased because more work is done in moving a unit charge through internal resistance of the cell. Terminal PD is decreased. Wait a second. Wait. So you have an EMF supply, and then you have a resistor, variable one. You have internal resistor also. Okay, so if the resistance is decreased, E is equal to IR plus IR. If this is decreased, the net current, net resistance would decrease. That means the current I would increase. So if the current I is flowing more through the battery, that means the lost volts would increase, which would decrease the terminal potential difference. The terminal potential will decrease because current in the variable resistor has decreased. Terminal potential difference is decreased because more work is done moving unit charge to internal resistance of the cell. That is also correct. Yeah, actually this is the one. This is not directly affecting the terminal potential difference. Terminal potential difference is actually, you see, terminal PD is actually E minus the lost volts. So it's the lost volts that are actually the cause of the reduction in terminal potential difference. Kirchhoff's two laws for electric circuits can be derived using conservation laws. On which conservation laws do Kirchhoff's laws depend? This is the easiest one. Kirchhoff's law is based on conservation of charge. Oh, no. And the Kirchhoff's second law is based on energy. A battery of electromotive force EMF 10 volts and internal resistance R is connected to 3 resistors of resistances R, 2 and 15 as shown. Current of 4.45 amps is in the resistor of resistance 2 and the current of 0.4 amps is in the resistor of 15 ohms. What are the values of R and capital R? Okay, so we can find out the terminal potential difference by multiplying 0.48. So PD across the, you can say, parallel relationship is 0.48 times by 15. So 0.48 times by 15. So this is 7.2. Okay. This also gives us the potential difference across the R, that is 10 minus 7.2. So 10 minus 7.2, that is 2.8. Potential difference across the R. Okay. Now we need the R. We know the potential difference across it. So V is equal to I R plus 2 ohms, right? So 7.2 is equal to 0.45 times by 2 plus 0.45 times by R, right? So R would be 7.2 minus 0.45 times by 2 divided by 0.45. So 7.2 minus 0.45 times by 2 divided by 0.45, 14, right? And now we can add the net current, 0.45 plus 0.48, that is, I think, 0.923. Sorry. Yeah, 0.93. So 0.93 amps is actually flowing through this. So V is equal to I R 2.8 divided by 0.93. So 2.8 divided by 0.93 is 3. So 3 and 14 are the correct ones. Okay. A battery of negligible internal resistance is connected in series with a thermistor and a fixed resistor of resistance 12 kilo ohms. Okay. Table shows the resistance of the thermistor at two different temperatures. Right. Potential difference V out across the fixed resistor is 4.5 when thermistor is at a temperature of 20 degrees. A 4.5 volts at 20 degrees Celsius. Okay, what is the V out when thermistor is at a temperature of 50 degrees Celsius? Right. Wait. So at 20 degrees Celsius, the resistance of thermistor also is 12 kilo ohms, right? So this means that initially it would be 4.5 volts also. Initially 4.5 volts also. But we need it at 50 degrees Celsius. Right? So 50 degrees Celsius, this is just 5 kilo ohms. So 5,000, just 5 kilo ohms. Sorry, 5 kilo ohms. So we can just simply figure out it using potential divider formula. So 12 over 17 times by 9, because as we saw earlier previously it was 4.5 also, so 4.5 plus 4.5 would be 9. So 12 times by 9 divided by 17, 6.35. What is the conclusion from the alpha particle scattering experiment? So there are two conclusions. Is that the atom is mostly empty space, and there exists a highly concentrated, positively charged mass at the center. Right, so let's see what are aligned with it. Protons and electrons have equal but opposite charges. That alpha particle scattering experiment does not show that. Protons have a larger mass than electrons. No. Nucleus contains most of the mass of the atom. Actually, yes, this would be the correct answer. So the nucleus is at the center, so there exists a highly concentrated, positively charged nucleus at the center. The entire mass, basically, almost entire mass is at the center. Americium-241 is a radioactive nuclide used in smoke detectors. It undergoes alpha decay to form nuclide X. This decay may be represented by equation shown. What are the values of A and Z? So this is easy. Alpha is 4/2. That means A is 241. Minus 4, and Z is 95 minus 2. So this is 237 and this is 93. A taut quark has charge of 2/3 E, where E is elementary charge. What is the charge of an anti-taut quark? Exact opposite. That means negatively charged, 2/3 E. Now, we remember up charm top have plus 2/3 E and down strange bottom have negative 1/3 E. So they're anti-equivalents. Down strange bottom have oppositely charged particles. Okay, so just simple table to remember. And that's the 40th question. That's the end of this paper. Hope you enjoyed solving this paper with me. If you have any questions, if you have any doubts, feel free to reach out. If you feel that I made a mistake somewhere, also please point out. I would love to correct it. And if you feel that I wasn't able to explain a particular question, also ask in the comments. I would love to help you out at any time. If you like this video, give it a thumbs up and turn on the notifications for future updates and subscribe to our channel. Until next video, take care of yourself. Bye-bye.